very briefly, this is a trick that I used to use to help me remember the ratios, the sine, cosine, and tangent ratios for the so-called special angles. So sine, I always thought of as the sine ratio. So sine, sine. And the reason why I need to remember it as the sine ratio is because as these angles increase, these ratios also increase. So you can also think about that in terms of the sine graph, right? Like if you look at the sine graph between 0 degrees and 90 degrees, what does it look like? It's an increasing graph until it gets to 90 where it hits a turning point, right? So it makes sense that as the angles are increasing, the ratios are also increasing. And we'll see why that's important in a moment. So the first thing is all of these ratios, I write them out with a denominator of 2, right? And then from there, I just have the square root of 0 at the top, square root of 1, square root of 2, square root of 3, and square root of 4, right? Square root of 0 is 0, and 0 divided by 2 is indeed equal to 0. Square root of 1 is just 1, which gives us 1 over 2. Square root of 2 over 2, well, 2 is the same as root 2 times root 2. So if you have a root 2 at the top, one of them will cancel at the bottom. So then you're just left with 1 over root 2. Root 3 over 2 is equal to root 3 over 2. And then this is equal to, square root of 4 is 2, divided by 2 gives us 1, right? So just by remembering that my ratio, to write my ratios with a denominator of 2 first, right? And then from there, I just go from 0, square root of 0, square root 1, square root 2, square root 3, square root 4, and that will give me the sine ratios for my special angles. Now cos I think of as the confused ratio, right? So sine is my sane one. Cos is confused because it just has the same ratios as the sine values, but in reverse order. So cos of 0 is going to be equal to 1, and cos of 30 is equal to cos of root 3 over 2, and so on. So if I have the values for the sine ratios, I can just then reverse them to get the cos values for my special angles, right? And then tan I don't really have a trick for. The key number to remember for tan though is the square root of 3. So we know that tan of 0 is 0. You can also think about that in terms of its graph, right? So this is what it looks like between 0 and 90. So tan of 0 is 0. Tan of 30 will be 1 over root 3. Tan of 45, I think, is almost the easiest thing to remember. It's just 1. Okay, tan of 60 is square root of 3, so there's our magic number again. And then tan of 90 is undefined because that is where it encounters an asymptote. I hope that that can help you out in exams where you're required to do stuff without a calculator, or even in maybe a tricky problem solving where you have to spot a relationship and that kind of unlocks the rest of the steps. This could come in handy.